would like to welcome Nadia Kasem from Snowflake, and she will talk about large-scale testing challenges. And I think that all of you had or have some challenges in testing, because you wouldn't be here if you didn't have any challenges. But the most curious I'm about is you'll never encounter. So Nadia, the stage is yours.
Thank you very much. Hi, everyone. Nice to see you all here, wanting to learn about challenges of a big scale. And maybe you won't encounter these specific ones, but hopefully you will be able to learn something and get inspired onto even in your projects, which might be smaller, might be bigger, definitely are different. So let's start with some introductions. I am an engineering manager of software development engineers in test team at Snowflake. And I'm here for 3.5 years. I started as an SDET, now I'm managing the team. And overall, I have over a decade of experience in testing and quality, spanning around web, mobile apps, desktop apps, IoT devices, starting with manual testing, but then automation. And in my personal time, I'm a proper cat lady with 2 cats, reading books, knitting on my armchair, so 100% cat lady. So, you know a bit about me. Now I'd like to get to know you, too. So let's do a warm-up. Please raise your hand if you have less than a year of experience in the field of testing. Cool. Hi, welcome. Less than 5 years. Nice, probably the majority. And more than 10? Perfect. Nice. Okay, and who of you works mostly with manual testing? Mostly or solely? Nice crowd. And who does mostly automation? Perfect. Okay, and who of you heard about Snowflake? And last question, who knows what Snowflake does, what it is and what it does? Okay, not that many. Then it's great that I have this next slide about what it is. So Snowflake is an AI data cloud. It's a platform for all data, all in one. Run on cloud infrastructure. You log in and you get everything. And what does this everything mean? There's storage of data, ability to share it, proper analytics engine, and ability to do analytics on large scale, and a lot of integration apps, possibility to develop them, distribute them. All is designed to scale easily, so you can use it in smaller projects and bigger projects. But in short, if you have the data and want to do high-performance analytics, you want to get quick results, you can use Snowflake, and it's very easy to use. You get the full package with additional things. And last intro about the role. I told you that I lead software development engineers in tests team at Snowflake, but what does it mean and what we do? We partner with our teams on quality. We are engineers, there is engineer in our name, and we work hand in hand with engineers in our teams to improve the quality, level up our quality game. We architect, implement, and maintain the solution test frameworks, work on builds. We, of course, with company this scale, we focus on automation. There's no place for manual testing in the process, because that would prevent us from releasing it as often as we do. But we cannot be the sole owners of quality, so what we do is we build the quality mindset with teams, so teams understand that quality is responsibility of all of us. So we are the quality experts, we drive test strategy, test plans, help establish guidelines and improve test coverage. And what is also important, we are the voice of customers, we advocate for them, so we go beyond verifying the technical specification requirements, but focus on user perspective in all we do to make sure that what we deliver is what our customers need. Okay, and what does the large scale mean in our case? So let's go through some numbers. We have more than 1,500 developers across many teams, several repositories, and also several time zones. We have engineering offices in Europe, in the US, and in Canada. We have more than 10,000 global customers, and this is not users. These are companies that use our product, and each of them has plenty of users of their own. And our users do, on average, 5.3 billion queries a day. So that's a lot. As you can imagine, plenty of things can go wrong with such scale, such complications, such setup. So we have to add many layers of quality and testing, and we have to accept that we are not able to test everything in every case, so we have a lot of safeguards in place to prevent us from having issues on production. And I will go through them. I will show you this from different perspectives. What challenges can we meet? What can we do to avoid them? But I won't go into low-level technical details, so trying to make it accessible to all of you, not depending on the size of the projects that you're in. So let's start from a story based on a true story from Snowflake connectors team. Let's start with what are connectors. Imagine that you have data in some place. We have connectors, for example, for Google Analytics, ServiceNow, PostgreSQL, or MySQL databases. You have data there. You want to move them to Snowflake to leverage our tooling and our SQL engine and all the apps that we have. And thanks to connectors, you don't have to go through all the hassle and complexity of writing and maintaining all the manual integrations. You can just plug into the connector, load the data, load the initial load of historical data, but also set updating it on increments, you set up the frequency. And Emilia Lędzian-Warszcz is working on the connectors team, and you can see her speech at 2 p.m. today, so just after lunch, to see it all from different perspective. But here I will focus on one of the cases that happened. So there was a long weekend. A team decided to do a test. Use that time, more than 2 days, and just to make sure that everything works fine, something that we all went through, something that we all see. It was a near-life situation, long-running test, transferring large amount of data. But the caveat was that we plan to stop and restart the replication to see how our system behaves. And after the long weekend, what we saw was that there is some difference between the data that we get in the source and the data that we got in the target. 3%. Doesn't sound like much, maybe it's not something that you should ignore, but if you look at the data underneath it, it's more than 40 million rows of data. So it would be bad if our connector misses this much, right? So we started investigations and working on it, analyzing what happened. We tried to find some smaller subsets of data that we can use to reproduce it, because we wouldn't like reproduce it on 3 or 4 days testing scenario. We were able to, after some testing, choosing the smaller, simpler, quicker operations and restarting the agent, we are able to reproduce it, but with just one line missing. So not 14, not 1,400, not 14 million, like on the original test, it was only one. And What we were able to spot after analyzing it for some days was that when agent was restarted during multi-row transaction, the transaction in the middle were faulty. So we saw that the missing row has the same timestamp as the row before it and as the row after it. And I don't want to focus on the investigation itself, though it is very interesting. I like hearing about stuff like that, learning from other people's mistake. But it is not something that you can easily use in your projects if you don't test operations like that. So let's focus rather on what we can do to omit such situations and what can we do to catch issues early. So I'll start with something obvious on a testing conference, on a test-related conference, but something that is very important and we need to think about it. So not focusing on happy paths. And you would be surprised how often, if we go through unit tests for some features, they cover only happy paths. They have coverage, so that's nice, but don't focus on any edge cases, even with experienced teams. So this is something that we have to remind ourselves constantly. Oops. Another part, non-functional tests. So here there was a chaos component. We also do, of course, performance testing, resiliency, security, and things like that might not be relevant in all of your projects, but I'm sure in every one of them there is some non-functional test that is important for users, like usability almost everywhere, accessibility, interruptions if you're testing mobile devices. If you do anything with data, then it's good to think about data corruption and analyze if there is any risk of losing data along the way. The next thing is shift left. I hope you heard about the concept, but if not, if you see the development from the moment of creation of the idea of the feature till the release of it to production, shifting left means thinking about testing early. So not only when implementation starts, not when implementation ends, but ideally from the moment that we think about feature and how we do it. When we do technical design for features, test planning is a component of it. So we go through what we want to test, what tests do we need. So in case we don't have the tooling ready or infra ready, we have plenty of time to work on it while development team work on the feature itself. And if you don't use some tests, don't decide to do some tests, it's also good to have it in the plan and decide for it to be conscious decision and not omit it because you forgot about it. And the other aspect is postmortems. So this case that I showed you, we found out about it during testing, but that's not always the case, right? We sometimes release issues to production. So what is important in this case is not only fix the issue and forget about it, because this way we don't learn from our own mistakes. Postmortems are great to understand what was the root cause of the issue, what gaps do we have that prevented us from catching it early. So it might be if you go through all those regression safety net that you have in your project, you might see that you might have done some static analysis, done some additional tests, and you missed that scenarios. Or maybe there is some alerting that is missing, and you could have spotted on some internal environments earlier. It's always good to go through it, not assigning blame, but analyzing what can we improve in the future to not make the same mistake twice. Another dimension of quality, end users. I'm sure that all of you were in a situation where you developed a feature, you worked hard on it, maybe implemented all the requirements, tested it fully, but when it went to production, it wasn't that successful. Might be because the user needs weren't fulfilled fully, maybe something changed in the middle of implementation, maybe the requirements weren't great actually, or there might be also some issues with usability or performance of it. But that is more of a job for product owner, right? Gathering end user needs. What does it do with quality? So, my opinion, using data in testing is extremely important and extremely useful. So if you analyze common user actions, what your users do, you can spot features that are accessed very often and focus on testing these cases. If you have a web page that has 90% of views and the other that has 5% of views, then probably your testing should align with that and focus on the features that are more used by customers, more visible, so issues there are also spotted more often. This is also high impact areas. So you might have spaces, places which are visited less often, but crucial to the business, connected with revenue, connected with billing, that also needs some additional attention. It's good to understand that and get that perspective into testing. User experience, of course, usability, and analyzing response times, how the product that you create is used by customers, handling error cases, things like that. This is very useful to shape your future quality roadmap. Peak usage patterns might help you with performance testing. If you know what are the peaks of usage if the users log in at the same time because you have some special event, or if it's used mostly on mornings or on weekends, you can use it to better design your performance testing scenarios. And it's also a great tool to track some issue reoccurrence and analyze if they're fixed, if they are not, where there are many issues. As I said at the beginning, for us it's very important to be customer's voice and use this data-driven approach to our testing to make sure that what we deliver is well received and handling user needs. But to get that, we also try to get close to end users. For the metrics, you can use some tools that gather it, but it's always important to also listen to your users, and there are many ways to do that. Some of you probably do some user acceptance tests if you have access to your users. That's very valuable. If you don't have this possibility, maybe you have a support team that works on your product and can connect with them, either shadow them or at least go through the cases that are there and see what customers report, what issues they are facing, what problems do they have. And at Snowflake, we also, before releasing products widely, we also go through stages like public preview and private preview when we release the product to feature to selected users, and works very closely with them to align on requirements and on feedback they get. So they shape the future of the features that we are releasing. For metrics and data, one component is what I already told you about, so data-driven testing, but also what's extremely important with such a scale is production monitoring, alerts, and metrics. We are not able to spot every edge case. Customer setups are very, very different. So it's very important to see and understand what's happening on production, because if we release something faulty to production, we want to get to know it from metrics and not from customer reports. This is the worst case if we found out that we have a bug because someone reports it to us. If we find it out earlier, we can react, we can change feature flags, feature toggles, so it might even not be spotted by many users. And the last component that's also very important is dog fooding. So how many of you heard that term and know what it is? We can raise our hands again. Not that many, that's nice. Okay, so dog fooding, eating your own dog food, is a term describing practice of using your own products. and products and services. The name comes apparently from some advertisement where they advertise that, advertisement for dog food, of course, when they advertise that their dogs eat that food too, whatever. But the term is there. So at Snowflake, we heavily use our tooling. Inside, we store a lot of data in Snowflake. We use our dashboarding solutions, monitoring solutions, alerting to see what's wrong. And this way, we are able to spot many issues on our internal environments before they hit production. And we also leverage Canary builds, so new releases first are released to our internal environments that we are using, only then to production if they go through it well. But throughout my testing career, I also used this approach widely, and the most interesting bugs that I found were the ones that I found during testing features on my own, like with some recording apps or time tracking apps. Using this feature also, like as users, help build you empathy for customers, spot all the frustrations that they see, spot all the performance issues. If you are using something and it's slow, you will definitely feel it and react to it differently than in testing. Okay, so the next case will be somehow around flaky test. Flaky test, so non-deterministic results. The same test run for the same code can give you different results. Once they can pass, once fail. So you don't get the correct signal from the tests. The team here was a team with front-end, web UI, having automation setup in Playwright framework. So very nice, new and shiny tool with good usability, quick. And the test coverage was high. And the tests were so quick that they were run as merge gates. If someone put out the PR, they had to run the tests, and the tests had to pass before they could be merged further. Well, if it was so ideal, then why I would be telling you about this case, right? Something had to go wrong. So the number of tests in this project started to increase quickly because they were very easy to write. You didn't have to do almost no setup. The framework was there in place, so it was even easier to test with E2E level than do some integration tests. You didn't have to prepare the mocks. You didn't have to handle any login. You can just tap in and do black box testing. So there were more and more tests in place. There were some collaboration gaps, like SDETs at first were able to review all the pull requests with tests and make sure that all the best practices are in place. But with more and more tests, they started to become bottlenecked, so they stopped it. Not all the tests went through SDETs. So like, some best practices weren't used. For example, maybe locators weren't very resilient, or waiting for elements might have been not working in all the cases. So test design issues. And for environment in infrastructure problems with more and more tests, they were very highlighted. If there were some issues, they were visible, but also through all the load, the workers had more load, so started becoming unstable. There were some inconsistencies in environments. And of course, there were also actual regressions in test itself. So if product is not 100% stable, we can't imagine that the test will pass 100% of the time. But even if there were regressions, it was the signal was so noisy that it was difficult to see which is the flakiness due to either test design on environment or which is the actual regression in test. So as you can imagine, very quickly, there was an opinion that started to be shared among whole team that our tests are flaky. which is not great. Which is not great because team loses trust in tests. The test quickly stopped being merge gates because if you run the test, they fail, and everyone just reruns them to get the proper result. Then that's not very useful, and it's slowing our flow and is faulty to developer experience. And because of that, we also lose trust in our build and product quality, right? Because we don't run tests as often, and we don't trust the results, so we don't know what's the quality of our end product. What happened next, where we started a lot of discussions among what to do next, how to fix the issue, is this framework all right, or maybe it isn't. A lot of opinions were shared, but they weren't really moving us forward. So what I won't focus in here is I won't tell you much about fixing flakiness itself, technical details of it. There are plenty of things you can do, and we have at least 2 other lectures covering flaky tests. What I want to focus on here is the approach to partnership with the team and cooperation to solving that issue. So as I said, we had plenty of discussions around the tooling and what can be done. And with this team is big, it has more than 100 of developers working on one monorepo, and they are in different time zones, so the discussions are also not easy because of that. But what we did, we looked at it from a different perspective. So instead of asking why not write this test, why not enable merge gates, we focused on where do we have gaps? Why do we want this test? What will we do if we disable them? Do we want to add some manual step in our release process and have all the teams go through their scenarios? Or are they okay with not checking that at all? Well, not really. We also talked with many engineers in the teams to understand what are their biggest hurdles, why do they oppose the change, why do they not trust the framework or the tooling, and also what are their expectations from the ideal test automation setup. And it changed everything. Even framing the questions differently, having everyone be part of the solution, change all the discussions, and we really started moving forward. And it turned out that, of course, the reliability of the framework is a major factor. If we have tests, we want them to be stable and provide a good signal for us. But there were a lot other factors additional to that, on top of that, that were also important, but weren't parts of our initial discussions. So when the team felt heard and understood, we talked more about a problem of ownership. So what happens if a test fails? Who should be responsible? Not having that diluted, but having it defined so we know what to do when a test fails. Proper guidelines and the strategy. As I told you, there were plenty of tests that were written not in the best way. We had tests on E2E level that should have been integration tests and sometimes even unit tests, but it was easier to write E2E. So what team highlighted is they know that we have the tools, but don't always know which test should be automated on which level and what are the best practices there. We realized that not everyone is aware of what we're doing among this big team. So communication about it and advocating for a solution can also be improved. And we also talked about cooperation and how can we partner in all that. So this was the first step, and when we talked about moving forward, we understood that the interviews are okay at this stage, but we need to gather some data to see if the actions that we are doing to improve the framework are actually working. So metrics. First is team feedback. We can easily gather that. But if we want to have it more structured, it should be done as measuring developer sentiment so we can see it over time improving or decreasing. Because if we wait for someone to come to us with feedback, they will either come with something great or something very bad. And it's more difficult to spot progress then. We can gather some metrics like code review turnaround, things that are easily measurable, and also give us signal on, not a direct signal on our tooling. User perceived metrics like time to build, time to review. This is also something that can be gathered and can show us how our toolings work. And system health. So, for example, framework reliability. How often does the framework itself fail? How many flaky tests we have? So you can gather metrics like that from surveys, tooling, but I know that in some cases you won't have them available or you won't have access to that. But I would say that you can still get data-driven approach to your roadmap shaping and test planning. I will show you one tool for structured interviews that can be used. I on purpose make it so small so you don't try to read it. So don't try to read it. I will tell you more about it. There's a link and you can Google that. It's a structured interview showing quality culture model. It's based on modern testing, and it's open sourced, available under this link. And what it is, it's a set of questions that evaluate different aspects of quality culture in your team. So they go through testing breadth, collaboration, tech depth, managing backlog, customer data analysis. So many of the things that I told you about. And how it works is team fill out the survey, showing, putting one number for the actual result now, and how they think that it should be. And in the result, we get charts like that, where you have a scale from 0 to 5. If you see the red dotted line, this is the goal. So this is what the team wanted. They think that planning testing should be at 5, test automation strategy should be at 5, etc. And the blue is what is the actual result. So what we now have in the team. So we should probably work on contract testing, simulations, integration tests, because there is a big gap between the actual result that we now have and the expected one. So even if you don't have all the metrics, you can work with your teams to get the interview data in more detailed and data-driven way. To sum it up, as I said, it's great to dive deep to issues, but to find an actual root cause, not focus on the symptoms, analyze what's the actual issue, and so it's good from time to time to take a step back instead of jumping to solutions. Trust, cooperation with the team, and building and maintaining it. And it's also important with surveys like the one that that I showed you. If you expect people to fill a survey that has hundreds of questions, if they fill it and nothing happens afterwards, I'm sure they won't be so eager to fill it after some time to measure what's the progress. So if we work with teams to gather the data, we should show the progress, and we have to come back with results and changes based on that. So it isn't done for nothing. Measuring the execution and success, it was also covered. Gut feeling is sometimes important, but quite often isn't enough, especially with bigger scale. And the last one is share your approach and progress openly and clearly to make sure that everyone knows what you work on, what is the plan, to gather quick feedback loop. And this might seem trivial, but this is actually something that is very, very important once you progress in your role. So even if you're great technically, if you are not able to sell your ideas to the team or to the people that decide on investments in your projects, then what does it change? If you know that something is wrong, you have a perfect solution, you can architect it and implement it. But if you don't get people on board, teams won't invest in that, right? So this is a skill that is very, very important as you start being senior or move to architecture role, to communicate clearly on the ideas, why they are important, and getting people on board to implement them. So, thanks for staying with me on this road through going through different dimensions of quality at scale. We focused on data from quite different perspectives, leveraging some insights, focusing on end users, understanding them, representing their voice. This helps us get closer to end or real-world scenarios. And quality-centric culture, so building a quality mindset that tests are default. We don't have to talk about this base stuff that we need testing. We just we have a common understanding that it is important. What we talk about is how to make them better, how to make them more useful, and how to catch as many things as we can before releasing it to production. Continuous improvement is also part of that, and analyzing what went wrong in the past and planning improvements in the future. So these all are essential to building robust, reliable products. That's all from me. Thank you very much. And if you have any questions or want to share some stories or challenges similar to that, I'm here. And if we don't manage to go through all of them, I will be available on our Snowflake booth today and tomorrow, so we can chat about it later too. We have a question there.
Hi, thank you for the speech. It was really great. My understanding is that you, in your company, have some centralized QA team, right? And it's not spread across the different teams, and the managers for QAs actually are from the QA team, right? How you can you explore more? Maybe I'm wrong, right? Can you tell me more about your structure of your QA teams?
Yes, of course. It is almost like that. The managers work with software development engineers in test teams, but the teams are embedded throughout the product. We are not in all the teams, and we don't strive to be. The goal is to join the teams that have some quality challenges, improve how we work, and then if everything works smoothly, our job is done, and we can move to other teams that has issues. And we try to use data also to decide on which areas are the ones that need our attention.
Oh, so you introduce the QA in the team, and everything is okay. The QA can be moved to another team, right? Or
yes, because we are not the ones doing all the testing. We provide the solutions, and we try to strive to make them generic, so they can be used by more than one team. But overall, the testing is done by the team itself, by the engineers in the team. So if we have a new feature, it has to come with all the testing. If we have a framework set up, the team should use it. So we, by design, don't want to be a bottleneck in that.
Okay, great, thanks.
Thank you.
Okay, thank you very much. And we are waiting for next question. Do you have any questions for Nadia? No.
Oh, there is one.
Also, thank you for the talk. It was really interesting. So I was wondering, you mentioned measuring team feedback. I was kind of curious, how did you exactly do this, and how often also did you do this?
Yeah, so our team, as that's are part of bigger engineering systems team that also provides test frameworks, works on CI, and as part of our bigger team, we do developer service. And actually, we get around 50% of developers answering them each quarter, which is very high. It wasn't that like that at the beginning, and that's because they really see the improvement. So all the feedbacks get analyzed. They help us shape a roadmap for the future. We focus on the issues that are highlighted, the most problematic ones. And we also go through all the answers that are put there, the open questions. So we strive to be very customer driven and treat users of our tooling as real customers.
Did you do something specifically to achieve that number of 50% of the developers answering it? It's really impressive.
Yes, we do a lot. So we leverage our manager net everywhere. We analyze which teams haven't responded yet, and if we see that some area doesn't get many responses, we ask the managers to highlight the importance of it to the team. But overall, we get growing results because really we do the changes that are there, that are highlighted there, and we share the results widely. So it's also all the results are opened. If you go through a service like Stack Overflow survey, it's probably interesting to you, right? To analyze it. So it's the same internally. People fill them out and see if other people have the same pain points or maybe different. And we also had some fun challenges in the past. Like if we reach 50% of surveys, then maybe our CTO might dress up as someone at product all hands. So there's also additional fun factor to that.
Okay, thank you so much.
Thank you.
Thank you. We have time for one more question.
Okay, thank you very much for lecture. It was really interesting. And my question is, you were talking about user insights, about spotting user patterns, and my question is, it's what you do as a quality team, or when you join in the team, you just teach them how to do that. Oh, it's your job to talk to the user, to make babysitting with them and ask them what you like, what you don't like.
That really depends on what's already in place when we join the team. We have many teams with different setups, so some have more mature data already and metrics, some not. So sometimes it is setting up the dashboards and gathering metrics in more usable ways so they are accessible. Sometimes we already have that in place. And the rest of it, we also shape the quality processes. So in some projects, we improve our user acceptance testing flows, or work with support team, and sometimes even end customers on calls to analyze that. So not sure if that answers your question, but we do all that depending on at what stage is the project. We also, for example, have some projects for our internal users. So it's a lot easier then to grab users, our actual customers, and to even go with them through the demo or through the flow. So depending on context, we do much. It's not always our role. We have also people oriented on product, like owners or PMs working on that. But if we see issues in that area, we try to fix them.
Okay, thank you very much.
Thank you.
Thanks. Let's thanks Nadia with applause. Big applause. Yeah.
Thank you.